What we found is engravings in a shell which is 400,000 years old. This is the oldest engraving that we're aware of, way older than we expected for this type of engraving. The location and the age of this really means that the most likely candidate for making these engravings is Homo erectus. So this earlier species, Homo erectus, to be associated with these types of engravings really pushes back the date to when we can start talking about these cognitive abilities that allowed a species to engrave a deliberate, abstract, geometric sort of pattern. Previously were thought to be in the domain of Homo sapiens, possibly Neanderthals as well. This had never been discovered before, even though these shells were collected more than 100 years ago by Eugene Dubois in the 1890s, even though they were studied in the 1930s. And even when I took the photograph itself, I never saw it. It only came up in the digital image. But once I opened up that picture, the first time I saw it, it was immediate. Those are engravings that have no other natural explanation. So there was two different dating methods used, and we had dating experts in Europe who have done these datings. They fall somewhere in that age of about 500,000 years old, or 500,000 years old. And this is unexpected for Trinil. People actually thought Trinil was older than that. So this will cause a rewriting of the age, and people to re-evaluate the age of not only Trinil but other sites in Java. Finding this particular bivalve, a shellfish, in the hands of Homo erectus, being engraved, used as tools, and proven to be a food resource, I hope will encourage other scientists to look at shellfish as really a potentially important element in human evolution.
Hi, I'm John Green. Welcome to Crash Course Big History, where today we're going to talk about the Planet of the Apes films. What's that? Apparently those were not documentaries. But there was an evolutionary process that saw primates move out of East Africa and transform the Earth into an actual planet of the apes. But the apes are us. And then we made the movie, and then some prequels, and some sequels, and some reboots, and now sequels to the reboots. Man, I can't wait until I get to see the 2018 reboot of this episode of Crash Course Big History. I hear they get James Franco to play me. So we're about halfway through our series, and after 5 episodes involving no humans whatsoever, today we are finally gonna get some people! Mr. Green, why are we already at humanity? I mean, if we're covering 13.8 billion years, shouldn't humanity come in the last, 2 seconds of the last episode? I mean, humans are totally insignificant compared to the vastness of the universe. We should be checking in on how Jupiter's doing. Fair point, me from the past. Jupiter, by the way, still giant and gassy. There's 2 reasons why we focus a little more on humanity in Big History. The selfish reason is that we care about humans in Big History because we are humans. We are naturally curious to figure out where we belong in the huge sequence of events beginning with the Big Bang. Secondly, humans represent a really weird change in the universe. I mean, so far as we know, we are one of the most complex things in the cosmos. Whether you measure complexity in terms of biological and cultural building blocks, or networks, or connections, I mean, we're kind of amazing. Now I realize that many of our viewers will be offended by our human-centric bias, but humans are amazing. I mean, we invented the internet, and we invented the animated GIF, and we invented Doctor Who, and then we invented Tumblr, a place where all of these things can come together. So 65 million years ago, catastrophe wiped out the dinosaurs, and we saw the adaptive radiation of a tiny shrew-like ancestor of humans that would look more at home next to a hamster wheel than in your family album. Let's set the stage in the thought bubble. So the slow waltz of plate tectonics continued to pull Eurasia and the Americas apart, expanding the Atlantic Ocean. Primates colonized the Americas, and separated by the vast Atlantic, continued their separate evolution into the New World monkeys, which is not a band name, although it should be. Then, around 45 million years ago, Australia split from Antarctica, and while mammals outcompeted most marsupials in the Americas, except animals like possums, Australia saw an adaptive radiation of marsupials. This, of course, meant that later, about 100,000 years ago, when the Americas were having their share of mammoths and saber-toothed tigers, Australia was having a spell of gigantic kangaroos, marsupial lions, and wombats the size of hippos. Then, somewhere around 40 million years ago, India, which had been floating around around the southern oceans as an island, smashed into the Eurasian continent with such force that it created the world's tallest mountain range, the Himalayas. Meanwhile, in Africa, primates continued to evolve, and 25 to 30 million years ago, the line of the apes diverged from the old world monkeys. And no, neither you nor a chimp is a monkey, nor did we evolve from the monkeys that are around today. Those are like our cousins. Moreover, we did not evolve from chimpanzees. The chimpanzee is a cousin as well, not an uncle. We are not more highly evolved than they are. Instead, our lines of descent split off from a common ancestor with chimpanzees about 7 million years ago. Then chimpanzees further split into a separate species, the bonobos. Knowing about this common ancestry tells us a lot about our shared traits with other primates. For instance, we all have fairly large brains relative to our body mass. We have our eyes in the front of our heads from the days when we hung out in trees, and depth perception was an excellent way of telling how far away the next tree branch was so as to prevent us from plummeting to our deaths. And we also have grasping hands to make sure, that you could hold on to the branch in question. Primates also have hierarchies, social orders, whether male or female led, that determine who gets primary access to food, mates, and other benefits.
Thanks, Thought Bubble. So our closest evolutionary cousins, the chimpanzees, can tell us a thing or two about shared behaviors. For one thing, while all primates have a hierarchy of alphas and betas, humans and chimps, who share 98.4% of their DNA, are the most prone to team up together and launch a revolution against the alpha male. We're also both prone to ganging up, roaming our territory, and beating up unsuspecting foreigners of the same species, and not for direct survival reasons. Chimpanzees have been observed finding a lone chimp male from another group and kicking, hitting, and tearing off bits of his body and then leaving the helpless victim to die of his wounds. And humans definitely bear this stamp of our lowly origin, where indeed the imperfect step-by-step process of evolution made us highly intelligent, but still with prefrontal cortexes too small and adrenal glands maybe too big. Aggression and bloodlust are definitely part of our shared heritage, and looking at more recent human history, does that really surprise anyone? Contrast that behavior for a moment with the more peaceful bonobos, who are female-led, and when a male in a group gets a bit pushy, the females are prone to gang up and teach him a lesson. When it comes to intergroup encounters in the wild, the male bonobos seem tense around strangers at first, until, usually, the females from each group cross over and just have sex with the newcomers, completely diffusing the tension. Talk about make love, not war. Bonobos are hippies. While our common ancestor with chimpanzees around 7 million years ago was more suited to living in forests and seeking refuge from danger by climbing trees, climate change in East Africa made things colder and drier, and many forests were replaced by woodlands and wide open savanna. Life in the savanna meant our ancestors needed to run from predators rather than climbing trees, so our line shifted away from the bow-legged stance reminiscent of chimpanzees and developed bipedalism, where our locomotion came from legs that were straight and forward-facing. There's still some debate about when bipedalism first began, but we know that by the first Australopithecines around 4 million years ago, our evolutionary line was bipedal. This also freed up our hands. Australopithecines were not very tall, standing only just above a meter, or just over 3.5 feet, and had brains only a little bigger than modern chimpanzees. They were largely herbivores, with teeth adapted for grinding tough fruits and leaves. Australopithecines may have communicated through gestures and primitive sounds, but their higher larynx meant that they couldn't make the range of sounds required for complex language. There was probably a lot of pointing and grunting going on, kind of like me before 6 a.m. By 2.3 million years ago, Homo habilis arrived on the scene. They weren't much taller than Australopithecines, but they had significantly larger brains, though still a lot smaller than later species. Excitingly, Homo habilis is known to have hit flakes off of stones to use them for cutting. Now, lots of species use tools. For instance, chimpanzees use sticks for fishing termites out of the ground, and they use rock hammers and leaf sponges and branch levers and banana leaf umbrellas. A lot of these skills don't seem to arise spontaneously just because of the intelligence of individuals, but like in the case of termite fishing, chimpanzees pass the information on by imitation. Primate see, primate do. In a way, this social learning is sort of cultural, yet succeeding generations of chimpanzees don't accumulate information, tinker with it, and improve upon it, so that after 100 years, chimpanzees are owners of highly efficient and wealthy termite fishing corporations. Similarly, as impressive as Homo habilis' stoneworking abilities are, we see very little sign of technological improvement over the thousands and thousands of years that habilis existed. Same goes for Homo ergaster erectus, who was around 1.9 million years ago. Homo ergaster erectus had an even bigger brain, was taller, and they even seemed intelligent and adaptable enough to move into different environments across the old world. They may have even begun our first clumsy attempts at fire, which is vital for cooking meat and vegetables, opening up opportunities for more energy and even more brain growth. But still, there's not much sign of technological improvement. Their tools got the job done. If it ain't broke, don't fix it. Yet 1.78 million years ago, we do see Homo ergaster creating a wide new range of teardrop hand axes in Kenya. By 1.5 million years ago, these teardrop axes had rapidly become common and had improved in quality and were shaped with a flat edge into multi-purpose picks, cleavers, and so forth. Archaeologists see this as the first possible sign of tinkering and improvement of technology that may have been transmitted by social learning. A faint glimmer of something new. Why is this important? Well, humans didn't get to where we are because we're super geniuses. It's not like the Xbox One was just invented out of the blue one day. It was an improvement upon the Xbox 360, which was an improvement upon earlier consoles, arcade machines, and computers, and backward onto the dawn of video games. In the same way, we didn't just invent our modern society by sudden inspiration. It's the result of 250,000 years of tinkering and improvement. This is where accumulation matters. It's called collective learning, the ability of a species to retain more information with one generation than is lost by the next. This is what has taken us in a few thousand years from stone tools to rocket engines to being able to have the Crash Course theme song as your ringtone. Progress. If there was collective learning in Homo ergaster, it was very slow and very slight. This may have been due to limitations on communication, abstract thought, group size, or just plain brain power. But over the next 2 million years, things started to pick up. Homo antecessor, Homo heidelbergensis, and the Neanderthals developed the first systematically controlled use of fire in hearths, the first blade tools, the earliest wooden spears, the earliest use of composite tools, where stone was fastened to wood, all before Homo sapiens were ever heard of around 250,000 years ago. Neanderthals even moved into colder climates where they were compelled to invent clothing. They used complex tool manufacture to produce sharp points in scrapers and hand axes and wood handles, and they improved their craft over time. While evolution by natural selection is a sort of learning mechanism that allows a species to adapt generation after generation with a lot of trial and error and death, collective learning allows for tinkering, adaptation, and improvement on a much faster scale with each generation and across generations without waiting for your genes to catch up. Anatomically similar Homo sapiens have been around for about 250,000 years, and throughout that time we've been expanding our toolkit from stone tools to shell fishing to trade and actual fishing, mining, and by 40,000 years ago we had art, including cave images, decorative beads, and other forms of jewelry, and even the world's oldest known musical instruments, flutes carved from mammoth ivory and bird bones. All this stuff came about as a result of collective learning. As long as you have a population of potential innovators who can keep dreaming up new ideas and remembering old ones, and an opportunity for those innovators to pass their ideas on to others, you're likely to have some technological progress. These mechanisms are still working today. We've got over 7 billion potential innovators on this planet and almost instantaneous communication, allowing us to do so many marvelous things, including teach you about big history on the internet.
So life for early humans was pretty good. Like, foraging didn't require particularly long hours. The average workday for a forager was about 6.5 hours. When you compare that to an average of 9.5 hours for a peasant farmer in medieval Europe, or the average of 9 hours for a typical office worker today, foraging seems downright leisurely. Quick aside, I work 30 minutes a day less than a peasant farmer in medieval Europe. That's not progress. Stan, I want more time off. Stan just pointed out that I have a chair, something that peasant farmers in medieval Europe did not enjoy, and I want to say that I'm very grateful for my chair. Thank you for my chair, Stan. Anyway, a forager would go out, hunt or gather, come home, eat, spend time with the family, dance, sing, tell stories. And foragers were also always on the move, which made it less likely that they'd contaminate their water or sit around waiting for a plague to develop. And with their constant walking and their varied diet, foragers were in many ways healthier than the peasants of ancient civilizations. They were also in some ways healthier than us, but we have antibiotics for now, so we live longer. For now. The classical view of foraging life is best expressed by Thomas Hobbes, who wrote, "No arts, no letters, no society, and which is worst of all, continual fear and danger of violent death, and the life of man solitary, poor, nasty, brutish, and short." Except not really. I mean, life for the average person in 12th century France was also a smidge nasty, brutish, and short. And the lack of wealth disparity in foraging cultures may imply greater equality between social rankings and even between the genders, since female gatherers appear to be responsible for the majority of food collected rather than the hunting males. And from that perspective, life was kind of ruined by the advent of agriculture and then later with states. As Jean-Jacques Rousseau said, the first person who, having enclosed a plot of land, took it into his head to say, "This is mine," and found people simple enough to believe him, was the true founder of civil society. What crimes, wars, murders, what miseries and horrors would the human race have been spared had someone pulled up the stakes or filled in the ditch and cried out to his fellow man, "Do not listen to this impostor. You are lost if you forget that the fruits of the earth belong to all and the earth to no one." And thus summarizes one of the great debates in the world of political science. Man, big history discusses everything. Now, it's possible that neither Rousseau nor Hobbes was completely correct, and that, like, private property and agriculture didn't create the glory days or end them. Like, as previously mentioned, all primates have a dominance hierarchy of some kind. Also, you don't need a wealth disparity to drive human beings to hurt each other. Like, surveys of excavated remains from the Paleolithic indicate a murder rate that was possibly as high as 10%. Now, those statistics are still disputed, but despite the relatively short workday, life in the Paleolithic sounds a lot less appealing when you consider the high murder rate and also the occasional infanticide. That's not even to mention the old or disabled people who, when they couldn't keep up anymore, were abandoned to die in the wild. I can't help but feel that I might not have thrived in the Paleolithic, what with my visual impairment and general lack of interest in hunting. Anyway, we call this the Hobbes versus Rousseau debate, and it's still unresolved. I mean, humans may have been corrupted in many ways by society. On the other hand, it's possible a lot of the crimes and follies of human history may just be symptoms of our coping with the bad wiring left to us by evolution. You know, humans are a bit of an obsolete machine. We aren't particularly well suited to the many lifestyle changes that have happened in the past few thousand years, faster than our genes can keep pace with. But how you interpret the lives of early human foragers largely determines your view of history and also the fundamental nature of the human character. Ask yourself which side you sit on. Is humanity fundamentally good and corrupted by technology and modern social orders? Or are we fundamentally flawed and in need of some sort of structure and authority? Or is there some kind of both-and way of addressing the question? Here at Crash Course, we don't have answers, but we are grateful that you're pondering these questions with us. In any case, collective learning was really good for our survival, but then, 74,000 years ago, disaster struck. A super eruption at Mount Toba on the island of Sumatra in present-day Indonesia clouded the skies with ash and cooled the climate. Plants and animals, aka food, died off, and genetic studies showed that this reduced the human population to a few thousand people. So as a result of this, we aren't exactly inbred, but there's more genetic diversity between two of the major groups of chimpanzees in Africa than there is in all of humanity. So this small group heroically recovered and spread out of Africa 64,000 years ago, colonizing diverse environments and continuing to innovate. For 13.8 billion years since the beginning of the universe, complexity had been rising in a powerful crescendo, but in the space of a few millennia, collective learning was about to make things really bonkers. More on that next time.
Now let's look at the first of the three great ages of human history. We call it the Paleolithic era. In Greek, paleo means old, lithic means of stone. So this is the era of stone tools. For archaeologists, the Paleolithic era goes back at least 2 million years because it covers the whole period during which humans or our ancestors made stone tools. So it goes back to the time of Homo habilis. But we're focusing on Homo sapiens. So for us, the Paleolithic era begins when Homo sapiens first appeared, somewhere between 200,000 and 60,000 years ago. And it ends with the appearance of agriculture about 10,000 years ago. So how can we study our ancestors who lived in the Paleolithic era? Well, we use two main types of evidence, archaeology and anthropology. The archaeological evidence consists of the remains that they left behind. Now this includes both the bones, the remains of their bodies, and the remains of the things they used, their stone tools, their ornaments, their artwork. Anthropology uses studies of modern societies that were probably quite similar to the societies of our ancestors. These are small-scale societies that foraged for their food and other resources. So, using this evidence, can we figure out how they lived? If you had lived in the Paleolithic era, what would your life have been like? How much of your social and family life revolves around eating? Probably a lot. Who you eat with, what you eat and where you eat can tell us a lot about you. And this was also true of our Paleolithic ancestors. But of course they didn't have restaurants and groceries. Instead, they relied on a technique that we call foraging. So what's foraging? Well, in a sense, all animals forage for the food and other things they need. That is to say, they look around the environment and they pick up those things when they find them. So birds, for example, they gather worms, they gather insects, and they pick up twigs for their nests. But human foraging is very different, and what makes it so different is the vast range of different techniques different communities use. So why is there such a variety? Well, this brings us back to collective learning. Each community develops intimate knowledge of its own variety and a whole series of specialist techniques for dealing with the particular plants, the particular animals that they have in their environment. So each community develops its own technologies over time. And this explains why human societies have managed to settle such a vast range of different environments all around the world. Archaeology can give us lots of clues about how our ancestors lived. Let's return to Blombos Cave on the Indian Ocean coast of South Africa. It was inhabited by humans between about 95,000 and 55,000 years ago, and it contains lots of evidence about how our ancestors lived. First, we find the remains of some deep-sea fish. Now, that's pretty impressive. It suggests that they were good fishermen, and it may even mean that they had pretty good boats. We also find the remains of shellfish, so they were exploiting resources on the beaches, and also of small reptiles, which they were catching. And we find the ash from fires, which they were probably using for cooking or heating, so they controlled fire pretty well. We also find very beautiful little stone tools, and very interestingly, some of these were hafted. That is to say, they used glues or fibers to attach them to sticks to make them more useful. And finally, and particularly interesting for an archaeologist, we find stones, clay-like stones that are known as ochre, on which we find little marks. Now these may be early signs of art, or they might even be early signs of writing. Now the other major form of evidence is anthropology. And what anthropologists do is study modern societies, as we've seen, that behaved a bit like them. In the Americas, in South Africa, in Australia, in parts of Siberia, there are still some societies today that depend at least partly on foraging. Now, of course, they're modern societies in all sorts of ways. Nevertheless, we can learn a lot about them, about what foraging means by studying those societies. In particular, we've learned that if you're going to survive from foraging, you probably need to forage over a pretty large area, so that even a large area can only support a very small population. You're also probably going to have to be nomadic. You're going to have to tour around that area to get different resources at different times of the year. So this means you're going to get very, very familiar with it, and you're probably going to travel to familiar campsites each year. Now, if you're nomadic, you're going to have to travel light. So foragers don't seem to accumulate much in the way of property. This may also help explain the fact that foragers seem to very often limit population growth. Now, foragers seem to travel around in communities, small communities of perhaps 10 to 50 people at any one time that are probably related to each other. But those communities were not isolated. We also know that they tended to link up with their neighbors. Very often what they do is they'd meet with their neighbors at a time and place where there were lots of resources to support a lot of people for maybe 2 or 3 weeks. In Australia, for example, in the Snowy Mountains, there's an area where the so-called bogong moths flourish for 2 or 3 weeks. So millions of bogong moths provide a feast for these sort of parties. Now, what do they do when they meet? Well, they share stories, they share ideas, they share dances, they may play games, but they also share people. So people move from group to marry or to get away from their enemies. So in this way, people circulate amongst these groups. So foraging groups exist in networks within which collective learning can take place. But of course, those networks are pretty small by modern standards. Because we're used to modern lifestyles, If you and I were transported to a Paleolithic community, we'd probably find life pretty tough. But studies of modern foragers suggest that if you were used to that life way, it could be pretty good. In some environments, there was a wide diversity of foodstuffs and different resources. Traveling around meant that life was varied, it probably kept you healthy. How do they see the world? Well, let's be honest, we don't really know. But studies of modern foragers give us a pretty good guess. Most modern foragers seem to think of the universe, the entire world, as full of spirits of different kinds. Spirits in the trees, in the rocks, in the rivers, in the stars, in the mountains. Some of them benign, some of them friendly, some of them really mean. It's as if they thought of the whole universe as full of life, as full of conscious life. And that's perhaps not such a bad way of thinking about the universe. But without records, it's probable that they didn't have a sort of modern sense of deep time or big history. Although we know that some big events, such as volcanic eruptions or perhaps asteroid impacts, could linger in their memories, sometimes for centuries or even thousands of years. As humans collectively learned more and more about their environments, they began to migrate into new environments. Now, at the time, these migrations would have seemed completely insignificant. No one would have really noticed them. But in retrospect, what we can see is that these tiny migrations were what led our ancestors to migrate around the entire world, developing new technologies as they did so. We know that some humans left Africa about 100,000 years ago, but real significant migrations began after about 60,000 years ago. We also know that just before those major migrations, human numbers dropped very drastically to perhaps just a few thousand. We know this because of genetic evidence, and it's probable that the cause was a series of massive volcanic eruptions. That's a reminder that there was no guarantee that our species would survive to the present day. Then, as if in a rebound, humans began to migrate faster and faster. By 50,000 years ago, we know there were humans in Australia. To get there, they must have had pretty sophisticated navigational skills because they had to cross quite a large body of water. They also needed the ability to use an entirely new suite of animals and plants to survive from. From 25,000 years ago, we know there are humans living in the icy conditions of Ice Age Siberia. To live there, they had to be able to hunt mammoth. Think about it. That was pretty tough. They used mammoth bones to build houses to keep warm. They also used bone needles to tailor very, very nicely made skin clothes to keep themselves warm. From about 15,000 years ago, we have evidence that humans have entered the Americas. So all in all, by about 10,000 years ago, we know that humans have settled all parts of the world apart from Antarctica. So there's nowhere else really, or there's not much room to settle now. Coincidentally, at about the same time, global climates began to change as the ice ages ended. Now these two changes, the settlement of the entire world and changes in global climates, would set human history off on an entirely new trajectory. Why?
We are a group of professional illustrators and animators who want to make Quranic education universal, free, state-of-the-art, and available to every human being with an internet connection. We have designed a course that we believe is the quickest, easiest, and most interesting course to understand Quran and Salah directly. This course will consist of short 3 minutes long, state-of-the-art illustration videos of entire Understand Quran Academy course. The course took 20 years to develop and has already been taught to hundreds of thousands of students by Dr. Abdul Aziz, the founder of Understand Quran Academy, and other teachers in the world. It has also been translated into many different languages. Now, for the first time ever using state-of-the-art illustration videos, this course is being made available to every human being on earth, so that every human being can learn Quran directly and understand Salah and prayers. Our target is not millions, but billions of human beings. By making and keeping the entire course free, we intend to benefit billions learn Quran directly. We want to make the course accessible to each and every human being on internet. Hence, we rely on donations to cover our cost to enable every human being access to this course. You can watch the initial episodes in the course that have already released to find out the benefit of course for yourself. Please do consider donating. Inshallah, it will be a source of constant sadaqah jariyah to you, your family, and your loved ones, as millions of people will continue to benefit from it as long as internet lasts. Once completed, the course will be freely available to anyone with an internet connection. Imagine a world in which everyone understands Quran directly. Imagine a world in which everybody who stands for Salah and prayers understand each word being recited. With your help, we can do it. God willing. Please do remember, our purpose is not to make a profit, but to build a service. Together, let's make Quranic education universal, free, state-of-the-art, and available to every human being.